Hello and welcome, everybody. Thank you for joining us. We're starting here at 12 o'clock Eastern on the dot. Welcome. My name is Joshua Wright. I am a SANS faculty fellow. I'm an author with SANS, and I am the author of the SANS Security 504 Hacker Tools, Techniques, and Incident Response material. Thank you, everybody, for joining us. Thank you for being here. Thank you for coming along with this journey. This webcast is going to be a little bit different than maybe some other webcasts that are mostly slide driven. When I was getting ready for this webcast, I decided that I wasn't going to spend a lot of time making slides because I feel like that's not always the best way to kind of communicate some of these complex topics. And instead, what I did was I put together a full blog article, and I have that open here, and I'll just share the link for this in Zoom here. And this is the content that we're going to be going over today. And I'm going to demonstrate all of this and talk about what's going on here and go over all of these amazing techniques here. This is a webcast that I'm doing, and one of my New Year's resolutions is to do more of this, to share more, to really, take the things that I'm learning and share them out with everybody and make it more accessible and make it more available. This morning, I'm learning a new framework, not a new framework, but a new for me framework for cascading style sheets called Tailwind, so I could do more front-end dev. And so, this is how I write notes. I use a tool called Obsidian for that. It's a free tool that allows you to use Markdown to be able to write all your notes on. And, if you take a little caution with it, it actually comes out kind of nice, and you can share it with other people. So I'm going to be doing a lot more of that this year. That's my New Year's resolution, and I'm going to spend more and more time doing that. And if you haven't already seen it, I also have some other material on the SANS website. If you go to the sans.org /webcast URL, there's a ton of stuff on there, and people are always sharing things. And there's a lot of opportunity for learning. This is a workshop that I did last year on cloud attacks and incident response. Oops, that's only the partial URL. Let me get the full one there. There you go. That's the full one. Okay. And this is one I did last year. This is still up and available. So if you haven't already checked that out, you can. This is hands-on workshop. So you can download the virtual machine and follow along with the recording and check all that content out. But today we're here to talk about cloud scanning for vulnerability discovery. So what we're going to talk about is how we can use scanning techniques to enumerate millions of IP addresses in the cloud, to identify target systems, to perform attribution or identification, what organization does this host belong to, as part of our reconnaissance. This might be a precursor to a penetration test, or this might be something that an attacker does, and you may be called upon to be able to perform incident response against these types of attacks. So this is the blog article that I wrote to accompany this material. If you want to check this out, there's also a PDF of this content. The PDF is straight out of my notes. So this is my notes. This is how the SANS blog kind of reformats my notes and things like that. But either one of these are really useful for you. And this is basically what I'm going to be following along on as I go through and do my demonstration using my notes here today. Now, I want to send a big shout out to this guy right here, Dahi, and forgive me if I'm Dahi, if I'm not pronouncing that correctly. A lot of this content was inspired by this article. I just kind of was searching the web and kind of found it one day trying to solve a problem. It was written a couple of years ago, and I've refined the techniques and done more and more with this. But I do want to give a shout out to this author that really inspired me initially for this and how a lot of this came about. So here's the problem that we're trying to solve. As an attacker, or as a pen tester, or even as a defense analyst, I want to identify where are there assets that my organization is using in a cloud provider's network, whether that's Amazon, Google Cloud, Azure, or DigitalOcean, or Oracle, or Alibaba, or any other cloud provider. What we want to do is to perform scanning so that we can scan these large networks to perform some analysis. Now, when I started promoting this, I kind of spoke a little badly about Nmap, and I kind of felt badly about that afterwards. Like, I love Nmap as a tool. Nmap is fantastic, and I use Nmap for assessments all the time, right? And so pseudo Nmap, things like this. This is a fantastic way to do discovery on a relatively small number of hosts. My rule is if it's less than 1,000 hosts and I've got time to wait, I'll use Nmap. And I'll scan it and I'll do some analysis and I can get results like this. This is great. And this scan for one host only took, less than half a second, but Nmap can be kind of fickle too. So for example, if you turn on version scanning and I say, well, I want to get more information on port 6789, 7443, 8080, and 8443, so something like that. And I do a scan and then I wait patiently. And I start to get a little annoyed and I press enter to tell Nmap to give me a status, and it says it's about 0% done on the service timing, and I wait some more and I wait some more. Nmap's a fantastic tool, and I don't mean to speak negatively about it because it's a gem of the open source community. It's been a mainstay tool for penetration testers and analysts for a really long time, but it can be kind of fickle. And it can come across a host that really causes it to just slow down dramatically. And it's very difficult to kind of work around that, to know, when it's going to slow down and still collect a lot of the detailed information. This will finish eventually. I tested it a little while ago. It took about 3 minutes on this host, but it's just 4 ports on one system, and 3 minutes takes a long time. Nmap is not the tool that we need to be able to scan a cloud provider's network. Last time I checked, Amazon in the US East 1 range had about 18 million IP addresses, and other ranges are similarly configured, some more, some less. But there's a lot of IP addresses in these cloud providers' networks. Nmap is not a tool that I could really use to scan all those target systems. It's just not going to perform for me. So we need to apply some different techniques. Now, what we're going to do is we're going to use Amazon to scan Amazon, to do some analysis, to look at what's going on inside of Amazon's network, and to try to perform some attribution to try to identify target systems. Now, in preparing for this webcast today, I've already set up an instance here of a target system. And just to show you this in my notes, I'll pull this over here. Right. This is the version of the content you got. This is the viewing version. This is the editing version. But I described some steps on preparing a Debian image. Now, I've used Debian for a long time. I have no love. I don't have a lot of hate for Debian. It's fine. It's just what I'm comfortable with. You could really use any Linux distribution that you want for this type of scanning. But I provided directions for configuring a Debian system. And if you're reading the article or the PDF that comes with it, these are the steps you can cut and paste just to configure that system. So what we're going to do after launching a Debian system in Amazon is we're going to install a couple of tools. We're going to rely on MassScan, Robert Graham's tool, which is fantastic, and then JQ, the JSON query utility. And then we're going to download another tool called TLS Scan, and I'll talk about that shortly. Once you download those things, you're just going to untar TLS Scan here, and you can delete the tar file. And then we're also going to talk about a Python script that I wrote with some help from Mark Baggett, one of our amazing SANS instructors, called TLS host names. And we'll talk about what that does and how we can use that in just a little bit. So this is something I've already done and configured here. This is just a T2.microsystem. So I went really, really minimal for this. You could certainly choose a bigger instance with more CPU and more network bandwidth, and that'll be faster. It'll have more capacity, and that would go great. I'm just using a minimal instance here for testing purposes, and you can kind of choose what's going to be right for you. Now, this instance type is in the free tier class. Now, I say free because if you've used AWS, there's all sorts of weird cost things. It's free until you pass this threshold, and then it starts costing you money. So, when we're doing this kind of scanning, know that when you're using cloud services, There is some free stuff, but it can cost you money as well, and just be aware of that. My AWS bill's about $20 a month. I don't have a lot running in it, but know that you may be incurring some charges when you use this kind of stuff. So I've got the system up and running here, and if I do a which mass scan, I see I've got mass scan here. I've got a TLS scan there, and then in my home directory, I've got this script. And with a normal Debian system, you get Python 3 as well. So this is all the tools that we need. We'll talk about some other things as well, but this is really it. There is an important element to this, though, that I want to point out. This instance is running in the US East 1 range, okay? So this instance, I've chosen to run in the region US East 1 for Amazon. The steps that we're going to look at are for scanning Amazon, AWS, US East 1 targets. If you're doing this kind of scanning for US East 2, then you would create your scanning instance in that same region, or US West 1, or AP South 1, or EU Central 1, or wherever these systems are. One rule that we want to make sure we follow is that when you're scanning the cloud, you are scanning within the same cloud providers network in the same region. We're going to be looking at AWS scanning here, but I'm going to talk about applying these same techniques to Google Cloud and to Azure as well. And we'll talk about kind of where some of the differences are, but the general rule is make sure you're scanning in the same providers network and in the same region. That way it costs you less, if anything at all, and it'll perform optimally to get all the scan results. So I've got the system up and running here, and I'm already SSH'd into it. What I want to do is to perform discovery. I want to scan this cloud provider's network to try to identify all of the target systems that I can find. Now, fortunately, Amazon makes a lot of this information available to us. If you look, Amazon has this reachability page where they do a ping test just to make sure all the networks are up and running. So this is just a service that Amazon makes available. And you can see these are all the regions in US East 1, all of these different networks here. And as I mentioned earlier, it's about 18 million IP addresses, and we'll actually count that in just a minute here. And you can see there's other regions. You can see US West, or in Europe, or in Asia Pacific as well. So Amazon makes this information available, as do other cloud providers as well. So Google makes it available, and Azure makes a list available of all the IP addresses they use. This particular format is not really that useful to me, but we can get this information in JSON format as well. So Amazon, at this URL, and I'll just share this here, publishes a JSON file with all of their IP addresses. And if we look at this information, we can see, here's the IP information by prefix. So it gives you the CIDR, or the classless interdomain routing CIDR mask information. And then it gives you the region information, border group, and some service name information, and then kind of when this has been updated. So this JSON file is available for us, and anybody can download and retrieve this information. Google makes this information available as well, and I'll give you this. Okay. Google's JSON format is a little bit different, but not too much, so you can get similar information from them. And then Microsoft makes this information available. You can't download it directly. You have to go to their website, then say, download, and then it generates a new link, and then you download that locally, and then you can work with that information. But we can get these lists of IP addresses from all the cloud providers. So we're going to work with that information here, and I'm going to use this JSON file. So what we can do is download this file. I'm just going to use wget to download that JSON file. And now I have it in my Linux instance, again, running in the AWS cloud environment. Now, if we look at this file, remember that all these regions are defined here. But remember the rule that we talked about at the beginning of this webcast. When you're scanning, you want to make sure you're scanning within the cloud providers network, which I am now, but we also want to scan within the same region. If I need to scan the region Africa South 1, then I want to create an instance in that region and scan from that instance. What I want to do here is scan from the US East 1 region, because that's where this instance is currently hosted. So what I'm going to do is I'm going to go to my notes over here. And in the notes that I gave you and in that blog article, I have a little JQ statement here. Now, JQ is the JSON query utility. It's a command line tool that allows us to be able to work with JSON files, to be able to extract information, to edit information, and to write little programs to be able to work with JSON content. If you've done a lot of cloud work, you've probably come across JQ before. And if you haven't, JQ is one of those tools that is frustrating to start with, but becomes invaluable over time. So learn a little bit of JQ, like, every now and then when you get frustrated, put it down and come back to it. But it's a really fantastic tool for working with large data sets in JSON format. So what we're going to do is we're going to use this code here. And what this code is going to do is it's going to take the IP ranges.json file with all those IP addresses, and it's going to run it through JQ, saying extract all the prefixes. That'll be all the IP addresses with the zone information or the region information. Then it says, if region is equal to US East 1, then spit out the IP prefix. Otherwise, don't spit out anything and then end. And then I'm going to make it in raw format, which will remove the quotes, and I'm going to sort it uniquely, and I'm going to spit it out to a new file. So I'm just going to cut and paste that command, and now it retrieved that JSON file, and now it has a new file called useast1-range.txt. And you would change this appropriately. If you're doing US West 1, for example, you would just change these two values to US West 1, and that would create the appropriate file for you. If we look at this US East 1 file, here we have all of the IP address ranges that are used for AWS's US East 1 network. Now, these are all CIDR masks, and I could do one of them in my head if I really needed to figure out how many IP addresses there are, but I wanted to have a better way to do it, so I ended up writing a little Python script for this. This is just a short Python script that reads from a file that has IP address / and then a CIDR mask, and then it calculates how many IP addresses there are. So I'm just going to copy this code here. I'm going to create a file called countips.py. Oops, I don't want to paste that. I want to paste the actual code here. Copy this. There we go. All right. So now we can run Python countips.py, and then if we specify that file, it'll tell me about how many IP addresses there are in that region. So in the US East 1 region, there's 17.7 million IP addresses. If we substitute East with West here, it'll run it again, but this time with US West 1, and it tells me there's about a lot less IP addresses, 1.5 million IP addresses in US West 1. So that can give you an idea of how many IP addresses you're going to scan. We don't need to use that Python script for that because, as we'll see in a second, the scanning tool we're going to use, MassScan, will do that for us. So we have our list of IP addresses, and I'm going to scan IP addresses in the US East 1 range. Now, there are 17.7 million IP addresses in this range. I'm going to make this a little bit easier on us. So what I'm going to do is just delete, most of this file, okay? I'm going to delete most of those IP addresses. I could scan all of them, but it's going to take me several minutes for the scan to complete, maybe 10 minutes or so, and nobody in this webcast wants to wait for that. So I'm going to trim this file just to show you a representative sample of IP addresses, and then if you were doing it on your own, you could scan all of the IP addresses, and that would be fine. Okay, so if I run this count IPs again on my modified file, we can see that now I've limited it to about 790,000 IP addresses. So still a lot of IP addresses, but a lot less than 17 million. Now, we have our list of IP addresses. What we want to do is start scanning those target systems. We're going to perform discovery. And we're going to perform discovery using TCP port 443. Now, TCP port 443 is where we're going to see most web servers, but we could certainly add other ports to this list as well. We're going to focus on TCP port 443 for discovery because a lot of cloud systems are going to be listening on that port number, but you could also scan for other ports. Anything that uses TLS service has to have TLS service though, and that'll become clear in just a couple of minutes. So this might be things like mail services, IMAP-S, SMTPS, but also Postgres, MySQL, RDP, TCP port 8443, anything that uses TLS will work here, but we're just going to focus on TCP port 443. Mass scan is the tool we're going to use to conduct the scanning, written by Robert Graham. Mass scan is very different from Nmap. They're both scanners, but mass scan is focused on performance. Nmap is reliable, and as long as you get the command line right, you're going to get some useful results, some useful information from that tool. But mass scan is much more finicky. With mass scan, you're in charge. You specify how many packets per second. If it's too many, you're going to get bad results. If it's too few, it's going to take too long. It does not do all the reconnaissance. It doesn't have all the scanning and enumeration capabilities Nmap has, but it does a good job at discovering target systems. So what we're going to do is we're going to use mass scan, and we're going to scan a portion of this US East 1 range, all 787,000 hosts. And we're going to do it by copying and pasting this mass scan command here. So I'm going to, and I just press Control L to clear my screen there. Mass scan, I'm going to read in the list of IP addresses for my range. That's the IP address CIDR masks. I'm going to save the output to this file, and I'm going to only scan for port 443. If you want to scan for other ports, you can do so. You can give it a comma-separated list here, and that's fine. And then I'm going to specify a rate. I'm scanning 100,000 packets per second, but I'm only using a T2.micro instance in AWS for Elastic Cloud Computing for EC2. If I were using a bigger instance, I could scan faster, but generally I try to stick to that number because I don't want to overwhelm my system and lose hosts. If you scan too fast, you're not going to get the responses back, and you might get some false negatives. So I'm going to keep it to 100,000 packets per second. Okay. Now, mass scan is going to start scanning these target systems, and notice how we didn't need that count IPs because mass scan does the counting for us. And it says, okay, I'm scanning 787,000 hosts for one port per host. And you can see here that so far we found 4,063 hosts. Now, the curious thing about this is it really only takes 30 seconds in total. It does have a little bit of a wait time, so it does a 10-second wait at the end just to see if any straggler responses come back. But it ends up scanning really fast. So it allows me to scan and enumerate all those target systems. One thing I don't like about mass scan is that I lose the output. When the command completes, you go back to this, but you don't find out how many hosts you discovered. So that's like a weird thing about mass scan, but we can certainly work around it with the data we have available. So in 30 seconds, we scanned almost 800,000 hosts for one port. If that was 17 million systems, then you could extrapolate it out. Maybe it would take a couple of minutes to perform that scanning. This scanning process is really quick and fairly easy. Now, if I was scanning from like my house, from my Fios connection, my fiber optic connection to the internet, I've got a lot of bandwidth, but I can't scan systems across the internet at 100,000 packets per second. But when you're in the same cloud network and in the same region, this becomes an opportunity for us. As an attacker, I can spin up an instance in the same cloud network and region as my target systems, and that gives me super fast access to perform reconnaissance and scanning against all those target systems. When we talked about at the beginning of this webcast, using instances in the same network and region, this is primarily why, because we need that performance to do this in any kind of a reasonable amount of time. Now, the output that we get is this mass scan file. Let's take a look at that. If we look at that file, we can see it comes with a little header and it has a single line at the end as well for a trailer. And it's only recording open ports. It says, okay, this is the port number, this is the IP address, and I think this is a date stamp. Yeah, that's the date stamp information for when it was seen. This is epoch time or epoch time, okay, or epic time, depending on how you pronounce it. So it's just a timestamp, and these all came in, in the same approximately second here. And if we run date-g at and then an epoch value, it'll convert it for us right at the command line. Only GNU date will do that. For if you have a Mac, the date command doesn't do that, but on a Linux system, you can convert it that way. So I have a list in this file of all the open TCP port 443 systems with IP addresses, but I don't want all of that data. I just want the IP address information. So I'm going to create a new file that's just a list of those IP addresses. And in your notes pages here, I've got an example of an awk command. So we can use awk to read from that file, only give me lines that match the string open, right? Because we only want things that are open, which really this is just going to exclude the header and the trailer. And I'm going to print column number 4. 1, 2, 3, just the IP address information here is column 4. Okay, and that's going to create a new file for us called US East 1 range.tls open. And if we had that file, now we have a list of just IP addresses. Great. Now, what if you scanned other port numbers, 443 and 8443, for example? The process still works, but you're going to want to specify that alternate port number at the end of the IP address. So going back to this awk command, you would do something like this. You could say print number 4, number 3, something like that, okay? This would work fine as well. And what this is going to do is extract the 4th column, which is the IP address, then the 3rd column, which is the port number, and then display that information. This would also work well for us as well, but since 443 is the default for what we're doing next, we don't have to specify that. But if you're using other port numbers, you would have to do this step and just make sure this output includes IP address and then the appropriate port number at the end of it. Okay, and again, this is all in the notes here. Okay, so this little command that I just did is all here. So this is a resource. I want you to use this recording, but I hope you apply this in the future. So I want to make all that as accessible as possible. All right, so let's recap for a second before we move on. I created an instance in AWS US East 1. I downloaded a list of all the AWS IP addresses, and I extracted out the ones for US East 1. I then took that list and ran it through mass scan, and I scanned for port 443 on every one of those IP addresses. That created an output file, and then I used awk to extract just the IP address information from that output file, and now I have this information here, a list of IP addresses. Great, I've done some scanning. I pat myself on the back, that feels pretty good, but it's not really useful to me yet. Yes, I've identified a ton of systems here, but I don't know what any of their identities are. Got a bunch of IP addresses, but which ones belong to my customer's network or my target organization's network? The next step we have to do is to perform attribution, to look at each one of these IP addresses and try to find out what are the attribution details. Now, normally we would do attribution with DNS, but a lot of these IP addresses will have reverse DNS names of just Amazon, right? So this points to, this is an Amazon EC2 instance. Well, yeah, I knew that. That's not really that useful to me. But there's another useful piece of information here. These systems are all listening on port 443, which means they have TLS certificates. And TLS certificates disclose a lot of information about that target system. We can retrieve that information manually. You could browse there with your browser, click on the certificate, but you could also use a tool like OpenSSL, sclient-host. I could use that host name if I want to, but I'm going to go for the IP address here. Just going to paste in that IP address and then port 443, for example, and that'll connect to the system and then give me the certificate information. There's a lot of information here, so I'm going to scroll up a little bit. So here's the OpenSSL command I ran, and it says, okay, this system has a common name of api.amberalertgps.com. Okay, now I don't know anything about amberalertgps.com. That's not my target. That's not what I'm interested in. But I can do this for every target in the IP address list, extract out all of that certificate information, and use it to perform attribution. So instead of a list of IP addresses, I have a list of IP addresses and then host names, organization names, or other details that are in the certificate chain information here. So how do we do that? OpenSSL is a fine tool for doing this one at a time. Like the sclient command is great for little things, but I'm not going to do that for all 4,800 or so IP addresses that Masscan identified as listening on port 443. Instead, what I'm going to do is use a tool called TLS Scan. Now, TLS Scan is another amazing tool. And what TLS Scan allows us to do is to take that list of IP addresses and then for each IP address, quickly connect to the server, get the cert, disconnect from the server, extract out details from the cert, and write it to a JSON file on the output. It's a quick tool, and it does this very quickly. It's not even making an HTTP request, so it's not trying to get a page or anything like that. It's just making a connection, doing the start TLS command, which will retrieve the certificate information from the web server, and then disconnecting. So you actually don't even see this in your web server logs. It's just extracting the certificate, which is before what most web servers log about activity on their system. So for an attacker, this is another pretty stealthy mechanism to collect information. It's certainly generating traffic, but it's not going to be anything that looks particularly suspicious. So what I'm going to do is I'm going to run TLS scan from the /op directory where I extracted it earlier. I'm going to get the list of IP addresses from this file here that I generated with awk from the Masscan output. I'm going to specify port 443, and you need to specify alternate ports as well. I have to give it this certificate. This is just a requirement for TLS scan to work, and I'm going to save the output here. Now, one other parameter at the end here is a timing parameter. How many seconds do you want to wait if the system isn't responsive? I'm going to make it 2 because I don't want you to have to wait for too long when we're doing this demonstration. By default, it's 10 if you don't do anything here. So I'm going to let that run as 2. Now, when you're scanning cloud networks, what happens is you encounter a lot of temporal systems or transient systems. These temporal systems are spun up dynamically, do a thing, and then get torn down. And that can happen really, really quickly. So between the time when I did the scanning and the time where I'm performing attribution has been, maybe 10 minutes or so, I'm seeing a lot of systems that aren't there anymore. You can see a lot of these network errors here, okay? These network errors are just telling me, hey, I can't reach that system right now. I can still reach a lot of them, but I'm not getting some of the temporal ones that have disappeared between the time when I scanned it and the time when I'm enumerating the certificate information. Another thing about TLS scan is that it only uses one concurrent thread by default. So it's using a timeout of 2-T2. If it doesn't respond in 2 seconds, move on to the next one. But it's only doing that for one host at a time. If I had an instance that was bigger than T2 micro with lots of CPUs and a lot of bandwidth, then I would probably bump that up, and that's -B. 4 CPUs, -B4 maybe, and that way you can really cut that time down by quite a bit. This is the slowest part, and this is why I reduced that list of IP addresses that I scanned in the beginning, not because of Masscan. Masscan will burn through a list of IP addresses, no problem. TLS scan takes a little bit longer to extract that output. All right. So at the end of this, I have a list of results here. I can see that I got about 4,000 handshakes back. And it took about 58 seconds to do that list. So you can kind of use that math to figure it out with the 2-second timeout that I specified. If I look for the JSON files here, I can see here's the original IP address for list. And then here is the results from TLS scan. And if I look at this, head-1, I can see that I get a bunch of JSON records. So this is not one contiguous JSON blob. It's a lot of different JSON blobs. So that can be detrimental depending on how you're processing this information. That's just how TLS scan generates the output. We can work with it, but this is the kind of information that we're getting out of this. Now, I think we saw this earlier. Here is the certificate information. So here's the common name information for api.amberalertgps.com that we discovered when we did the OpenSSL client command. It's just automating, collecting that in a lot more information, and then putting it into this big JSON blob here. Now, again, JQ can be valuable for us because I can pipe that to JQ, and I get a prettier version of it, just formatted a little bit easier for me to read, and I can see the subject information here. But what I want to do is extract out that information for all of those results. If we look at this file, if we look at that file, there's 3,915 results. Those are 3,915 targets that we found. What I would like to do, just to make it easier for me to read, is to extract out that information and have maybe a CSV file that is IP address, comma, and then the common name or other information about that target system. Again, we can use JQ for that. I've got a JQ command here. So what I'm going to do is I'm going to cut and paste this from your notes. And I'm going to cat that file, and I'm going to pipe it to JQ. And with JQ, I'm getting the IP address information. And then I'm getting the certificate chain information. There may be multiple certificates, certificate chain, multiple links. And I'm going to extract the subject CN. The question mark says, if that doesn't exist, then just continue, because sometimes there won't be, rarely there won't be a certificate chain in the certificate. And then I'm just going to pipe that information, join it with a comma to make it CSV, and I'm going to pipe it out to the CSV file. Great, that only takes a couple seconds. And now if we look at the CSV file, we have a list that's a lot easier for us to look at. We have the IP address, comma, and then common name information or whatever the subject CN in the first certificate in the chain is. But then for other certificates in the chain, we get all this additional information. And this is just the root to intermediate to host authority for all those different certificates. Now, these certificates are not guaranteed to be real, right? True or real, they're not guaranteed to be valid, but many of them will disclose useful information for me that gives me insight about who these target systems are and what organization is using those platforms. Now, this is useful information, but what I found is I ended up going down a rabbit hole of, well, other fields like subject alt name may also have useful information. How can I extract all of that? And I went down this rabbit hole of trying to do it all with JQ, and it became a JQ nightmare. And so I ended up just writing a little Python script for it. The TLS scan hostname script is written by me and Mark Baggett, and thank you, Mark, for all of your help with this script. And what this script does is it reads from that TLS scan output JSON file, and then it looks at the certificate chain, the subject CN, the alt name, and then other fields that might exist inside of that certificate data. So it's just another way to get the same data, but to format it in a little bit of a different fashion. So what I'm going to do is I'm going to clear my screen. I'm going to run this script, and I'm going to give it the JSON file that's the output of TLS scan. Okay, and it will give me information that looks a little bit neater, but notice how this IP address is repeated multiple times. What I ended up doing here is making the IP address repeat for every host. So it's one host per line. And so let's generate that entire output file. And what do I want to call this file? I've got the name here. Cloud targets. Attributed.txt. Right. So now I've got that list of all of the IP addresses and all the attribution. Right. I've scanned the cloud network, and now I can go through here and identify all of the targets that I might want to attack in the cloud provider's network. Quick sidebar. I was going over this with my friend Mick Douglas, amazing science instructor, amazing analyst, just a brilliant guy. And he said that he was working a project where a customer wanted this kind of an assessment. We want you to do discovery of all the cloud assets by performing scanning. Mick owns a consulting company, and he came in at one price, and the customer said, that can't be enough. And Mick said, what do you mean? Says, you're not charging us nearly enough for this. This other consulting company charged us, I'm going to make up, 8 times what you're charging us for this. Okay, we did it in an hour. Okay, this is the kind of thing where I find people look at this problem. How do I scan the cloud? Millions of IP addresses. How do I perform that attribution? And it seems intimidating and overwhelming. Until you break it down into reasonable steps, extracting the IP addresses, mass scan, TLS scan, a little bit of Python or JQ to massage the data. And now you have this kind of a list, and it's really easy to look through this list and try to find target systems. So for example, I tend to pick on Ring, the people that make doorbells, not for any particular reason, but because I know they have a lot of target systems in this range. And I'm going to search for Ring in cloud targets-attributed.txt. And it gives me a lot of results, okay? And if I want to try to eliminate some of those false positives, I can search for Ring dot, for example. Okay? And that still gives me some false positives like share spring, seamless shiring. I don't know what that is. Excuse me. But we can see qa.ring.com, ring.com here, okay, lots of ring.coms, but also things like this. Okay, this is useast1.prod.rms.ring.devices.a2z.com. Now, I don't know what that target system is. I'm not authorized to attack Ring or anything, and I'm not doing that. But this is the kind of analysis that becomes really valuable for an attacker, because normally rely on OSINT or maybe certificate trust lists or other public sources of information to perform this kind of reconnaissance, which is great. We should do that too. But by scanning a network in very short order, we can build a list of targets that might not show up any other way. Now, there's a couple of things that I think are important to point out here as well. These names look like host names, and they are host names, but just because it's a host name doesn't mean it's going to be in public DNS. Now, for example, because I've tested this before, that host name is not in public DNS. So I can't reach that host name directly. That's important to me as an analyst, because a lot of web servers will use a virtual host configuration or a vhost. A vhost basically says, I'm a web server, and I do lots of different websites, API servers, login servers, media servers. I got lots of stuff going on over here. How do I know what website you're looking for? It's the one you ask for. So when you browse to a site, there's a parameter called host that goes in the header that makes a request. And the website says, oh, host header useast1.prod.rms.ring.devices.a2z.com. I'm going to send you to this particular web function and return that result. If you just browse to the IP address, the web server might not have a vhost for that, or it might not give you the actual content that is intended to be used for this host name. So a lot of the time what I'm doing when I'm doing this kind of an assessment is I'm manually editing my Etsy hosts file. So I'm going to just edit it. I'm editing VI, but use whatever you're comfortable with. And then what I would do is, if I remember to get the IP address here, I will make my own manual entry. Okay. This way, now, when I try to reach this host name, it will go to that host name associated with the corresponding IP address. And that will help me navigate to the appropriate virtual host on the web server. Is it perfect? No. And there are some problems with this. Sometimes I'll do OSINT and I'll Google or use Bing to search for a specific IP address. I'll try to find out other resources because, you know, I don't know, maybe this host name that's on the default certificate is not even what the website uses for other services. So I'm always trying to keep that in mind. I may be seeing a small portion of that website, but there may be many other things there as well. So I might not have a whole picture from the scanning, but it still gives me a lot of data and a lot of information that I can start to work with. I see there's some questions coming up here, and I'm going to jump to those in just a second here. Okay. Now, this was about vulnerability discovery, and certainly making your DNS map locally is an important part of that. But one tool I would recommend that goes even further is to scan with Eyewitness. If you have a list of hosts, then you can browse to them, start using conventional tools, vulnerability assessment tools, Metasploit, even Nmap to scan those target systems. But Chris Trunser's Eyewitness tool is another great choice here. Chris wrote a tool that is a scanner, but instead of just doing a port scan or something like that, it takes a screenshot of what that website, that VNC server, or that RDP server looks like, and it generates an HTML report. So using Eyewitness and generating a list of targets allows me to open this page up and kind of scroll and see what's interesting to me. It can also identify vulnerabilities here, like this particular Tomcat server here with default login credentials. Okay, so this becomes a really useful tool for performing a lot of that kind of analysis. A couple of words on defense, and then I'll start taking a look at some QA here as well. How do we defend against this? Okay, and I'm starting with a little warning. I have no great answers, okay? We could use security groups in your cloud environment, Google, Azure, AWS, or network access control lists, or NACLs, okay? This is like using kind of firewall rules on a host or on a group of hosts that you're using in the cloud to limit unauthorized access. Great. If you don't need to expose your systems in the cloud to the internet, then use the features the cloud provider makes available to control that, security groups and NACLs being two options there. Okay, that's fine, but what if the system is intended to be on the internet? What do I do then? Well, again, I don't have a lot of great advice here, okay? My recommendation is don't worry about scanners. If you have to have a system on the internet and the system has to be publicly accessible, you're accepting risk. There's going to be risk associated with that target system. That's just part of the business risk that we use for systems on the internet. Know that systems can be scanned. My advice is don't worry about the scanning piece. Worry about what happens after scanning. Let's say the attacker identified that target website, and then they start running Kite Runner or other enumeration tools against a target system like FFAS, the Fast Application Fuzzer, okay, or WFuzz, or tools like that, okay? That will leave a lot of web logs. That's where threat hunting, that's where incident response, that's where monitoring systems really becomes a lot more useful. Can you detect this kind of a scan? Probably not. Although there's a ton of activity, from your perspective, one host at a time, one TCP port 443 packet from mass scan, and then maybe 5 or 6 packets from TLS scan per host. That's not a lot. So there's really not a lot to detect from a defense perspective. It's what happens after your scan that is much more interesting to us. So again, all of this information is in this little guide here that I put together, and that's available on the SANS.org website and the link that I shared earlier. And if you want to get the PDF version, here's the PDF. It's exactly what I just walked through. You can cut and paste all these things and do it all on your own. Okay. I do want to point out that I have a couple of webcasts coming up. If you go to sans.org/webcasts, and then you click on penetration testing and red teaming, it'll kind of show you the kind of pen test red teamy things. There's a lot of stuff going on, but if you click on that, it'll bring you to this workshop. I've got another cloud workshop coming up for cloud application attacks, where we'll attack Microsoft 365, we'll look at vulnerable bucket storage mechanisms and a whole bunch of other things here as well. So that's coming up later on this month. Note to self, need to prepare for that. So if you want to sign up for that, the difference between a webcast and a workshop is hands-on, and it's usually 2 to 3 hours, where a webcast is 1 hour and it's just me talking. But the workshop, you'll download a VM and you're going to do things. It's going to be practice. You're going to have hands-on, and this is all content that I've excerpted from my Security 504 class. All right. Well, I got through that pretty good. So let me see. There's some questions here. Okay. Sean says, "What's your opinion on Tenable for cloud scanning?" I think the add-on providers, like what Tenable does and things like that, is great. But the question to ask is the cost worth it versus what we can do here? I'm not familiar enough with the product to know all the features of it. It's nice if we can have somebody else do that work for us. And the nice thing about Tenable is they scan once and they just give you the information that's pertinent to you. You can reproduce a lot of that, and I'm sure Tenable does this and a whole lot more to be able to get that result. The question you need to ask is it worth it? Can you get better results, right? Are there things you can do that Tenable can't do? That's more of a personal evaluation, but if that tool works for you, then I'm all for it, okay? Jared says, "Do we need permission to use this as a discovery option?" That is an excellent question. In the beginning of this documentation, I say there's 2 rules. Rule number 1, always get permission, okay? Now, I'm not a lawyer. I can't provide you legal advice. My interpretation of AWS leads me to believe that I am okay doing this because I'm not attacking anybody's networks without permission. Now, attacking, what does that mean, okay? Am I attacking by scanning? I don't know. My attorney says I probably won't go to jail. There's like a 90% probability I won't go to jail. So, but this is something to talk to your legal counsel about and to make sure it's going to be acceptable. I feel comfortable doing it because my intent is to improve the security of my customers' networks, but that's something you should probably discuss with somebody that understands legal implications a little bit better than me. Sergio says, "Are you afraid of being caught and banned by the cloud provider when you do such kind of scanning?" Okay. Am I afraid? No. Am I going to get caught? Look, the cloud provider can ban you for anything. Okay. Their ULERs are so broad that they could ban you for whatever reason. And we've seen that happen, not for this, but a couple of years ago, we had a holiday hack challenge where we hosted a Linux instance, and it was doing S3 bucket discovery, and Amazon shut down all access to that IP address. Not blocked us, they shadow banned us. So it looked like things weren't working because we could still talk to S3, but nothing worked. They can do that. Do I worry about that? Not really. Worst thing is they terminate my AWS account, and that would be a bummer. But I would argue the point and see if I can get it reopened here. Maybe if you're concerned about it, don't use your corporate AWS credentials to do this. Maybe have a separate AWS account for this, to try to kind of limit that a little bit. But again, I'm not a lawyer. I'm not providing you legal advice. Check with your legal counsel about this stuff. Okay. I don't want to butcher your name. Nice, sir. Olusegun. Okay, and I apologize for that. Would Nmap asked to do only a SYN scan on one port be significantly slower than mass scan on the same CIDR range? Yes. Mass scan is designed as a a send and forget. With mass-scan, the architecture has one thread that sends. It doesn't care about what's going on in response, it just sends. And then a different thread just listens. Oh, got a response. Oh, got a response. And it allows mass-scan to be much, much faster at the cost of reliability. Mass-scan can be very unreliable if you're not careful with your timing and with your bandwidth capabilities, things like that. Nmap will send and then wait for a response. Didn't hear anything, but I have to do it 3 more times to see if that's still not there. Send, listen, and that can take a lot more time. Nmap is going to be much more reliable. You're going to get much more consistent results, but it's really not intended to be scanning millions or hundreds of thousands of IP addresses. That's where mass scan becomes useful. Not dogging Nmap, it's an amazing tool, but I'm only using it for like 1,000 hosts, more than 1,000 hosts, and I'm not using Nmap. Okay. Leonardo says, if you don't find a cert on 443, someone tried to get clever. Yes, they did. Okay. Marcus says, is there any concern with using mass scan against public IPs in the AWS cloud? Are the scans disruptive enough to raise any alarms? I think the scans that we're doing here are really minimal and really not that invasive. With mass scan, it's one packet, TCP port 443, SYN. Did I get a response? Yes or no? I'm moving on to the next system. So scanning is really, really minimally invasive. It's one packet for the scan, and then maybe 5 or 6 packets for TLS scan to get the certificate if the system is listening. None of it's malicious. None of it's malformed. Everything is above board, just using TCP and TLS the way it's intended to be used. All right. Monitoring with Shodan is a great option if they've got the results for it. That's awesome. Okay. Have you thought about, and what's your strategy with different SSL certs for virtual hosts? Yeah, this is tricky. So when you have a web server that has multiple SSL certificates, then this kind of discovery doesn't really work unless you can integrate some other kind of reverse DNS or forward DNS lookups, things like that. What I will do sometimes is use things like crt.sh, and this is a certificate search resource, and then look for a domain name. This is more OSINT collecting of information, but we can use certificate trust lists to get a list of all the certificates that have ever been issued to an organization in a list like this. Well, not ever, but for the past many years. Okay, so this gives me a list of lots and lots of certificates, but it also gives me lists of host names, wildcards, different platform information. So you can learn about like different domain names, right? sans.edu versus sans.org, for example. This is something that is really useful for discovery of cloud targets. The kind of scanning with mass scan and TLS scan when hosts are using multiple TLS certificates doesn't work nearly as well. Yeah, got it. Thanks, guys. Appreciate that. All right. Yeah, so Leonardo says, Shodan query on search will blow your mind. It puts 0 packets on the wire. It's an amazing resource. I typically use crt.sh, but Shodan is also amazing as well. And Tara says, are there better ports to look for source control managers of cloud native app services and functions? Okay, so Tara, it's a great question, and it's a good idea to maybe start building your own list of port numbers. So in my article here, I said, here's some ports that just came up off the top of my head, but things like K8S, I can't remember. I want to say Kerberos, and that's not the right word. Okay, different services like that. Anything that uses TLS can be a valuable target. So MySQL is a great one. Postgres, Oracle, anything that uses TLS is subject to this kind of discovery. It's really just building the port list of things that you think are going to be prevalent. That's kind of the secret consultant sauce when you build those things on your own, and now you're getting results that other people aren't getting. All right. Hey, well, that's it, everybody. Thanks very much for coming up at the top of the hour. Thank you very much for SANS for the chance to be able to host this, to be able to share this content with everybody, to give me the platform to be able to talk about these things. Check out sans.org/webcasts for some upcoming things, and definitely check out my workshop that are going to be happening later on this month. Until then, Happy New Year, everybody. Take care of each other. I'll talk to you next time.